Okay, so this lesson is kind of a random lesson that gets pushed into this chapter, but we are going to still talk about it. So, scatter plots and lines of best fit. Let's first go over some vocabulary because this could be new, especially if you didn't cover it in 7th grade. But scatter plots is a scatter plot is used to investigate the relationship between two variables, and line of best fit or trend means how the points in the scatter plot are related to each other. Okay, so I know these graphs are not the easiest to see, but if you look at the direction of these points, okay, I know that they don't make a perfectly straight line, but let's figure out what kind of relationship they do have. If I look at the direction that these dots are going, they are going in the positive direction because they're going upward. This is a positive association or correlation or relationship, whatever you want to call it. If I look at the second one, they are random dots that are going downward, and this makes it a negative association or correlation or relationship. And then you have the third type, which is whenever the dots are completely random, there's no certain order. It doesn't look like they're going in a certain direction. This is called a no correlation or no association or no relationship, okay? So that's the basic of the vocabulary. What we then learn is how to find that line of best fit. And what I mean by line of best fit is the y equals mx plus b, okay? Well, I know what you're thinking. You're thinking, well, miss, there's no way because it doesn't form a perfect line. Well, this is where we take our graphing skills and see what works best, okay? So if they want us to see A, B, C, or D, which equation would best fit this line? Okay, so let's first break it down. Think of this as the slope. Is the slope positive or negative? Is the relationship going upward or downward? And since the relationship is going downward, I know that it's going to be a negative slope. Well, if I look at A, B, C, and D, A is positive slope, so it's not A. B is positive slope, so it's not B. And it could be C or D because of the slope. They're both negative. They both also have a y-intercept of -2. So here is how we identify which one's correct. We graph them. So if I plot letter C, okay, I start at the y-intercept, which is -2. Then we're going to graph the slope, which is down 3, right 5. So from -2, I'm going to go down 3, right 5, down 3, right 5. To go the opposite direction, I'm going to go up 3, left 5, up 3, left 5. And did you notice that the new dots that I plotted go really well with the dots that are already there? Well, let's see if that's the same case when I do letter D. If I do letter D, we're going to start at -2 as well, but we're going to go down 5, right 3. So if I go down 5, 1, 2, 3, 4, 5, and right 3, down 5, kind of off the page, right 3, up 5, left 3, up 5, left 3. Do you notice how it's off of the dots that are already there? So the one that closely relates to number 1 is letter C. Let's do the same thing for number 2. So first, let's do process of elimination. Is it a positive slope or a negative slope? Well, since this is going in a positive direction, it's going upward, it's positive slope. So I can eliminate C because that's -2, and I can eliminate D because that's -1/2. So now we're going to see which graph is closer to the points already graphed there. So we're going to start at +2, and letter A says we're going to go up to right 1. Up to right 1, up to right 1, up to right 1, up to right 1, down to left 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 1. So if you're looking at it the way I am, it's pretty close to the dots that are already there. if I do the same thing for letter B, but this time I go up 1, right 2 from, if I go up 1, right 2 from positive 2, up 1, right 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 2, down 1, left 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 2. It's going in a completely different direction than the dots that are there. So my answer is letter A. So let's do that same thing with 3 and 4. So 3, let's first eliminate based off the direction. This is a positive slope because it's going upward. So I can eliminate B and I can eliminate D because they're both negative slopes. Then we're going to see, do they follow more of the A equation or the C equation? Well, first, what in the world is the y-intercept? Well, the y-intercept for both is 0. That means it starts at the origin. And the slope for letter A is 4 over 1, so that means right up 4, right 1, up 4, right 1, down 4, left 1. And you can already notice that it's not going in the same direction as the points already plotted. So if I try letter C, they want us to go up 1, right 4 from the origin. So up 1, right 4, down 1, left 4, and that is closer to the lines or the dots that are already there. So letter C. Number 4, process of elimination. This one is a negative slope, so I can eliminate the positive slope. So the positive slopes are A and C. Then I want to graph. If I look at letter B, they gave me a y-intercept of positive 2. It's hard to see and they want me to go down 1, right 1. So down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1, up 1, left 1, up 1, left 1, up 1, left 1. That one's pretty good, pretty close. So let's see if letter D does something better. This time, though, letter D, they want us to start with the y-intercept of negative 2. So that starts down here. And then they want me to go down 1, right 1. So they want me to go down 1, right 1, down 1, right 1, down 1, right 1, up 1, left 1, up 1, left 1, up 1, left 1, up 1, left 1. But if you notice, it is going the same direction, but it's not within the dots that are already there, as good as the other one was. So letter B is my answer. Okay, so when we're talking about line of best fit, we're talking about the best type of line or equation that can go through a set of dots or points that are not in a perfectly straight line. When we want to find the line of best fit, but we're only given a set of values in a table, we have to utilize our calculator. So what is linear regression? We've already talked about this before. It is a method for finding a precise meaning the closest line of best fit given a set of data points. Okay, so we've done linear regression before. We're just given a lot more data points this time, so we're gonna just jump right in. So we're gonna type this table into our linear regression or our stat table. So remember, the top numbers at the top of my table are my x values, so those all go on the left. So 0, 10, 20, 30, 40, 50, 60, 70, 80. And then my y values go on the right, so make sure you type them in correctly. 80.1. Be careful with double digits like 77.5. Sometimes the calculator button sticks, so make sure you really grab a hold of it. 68.7, 57.4, 42.4, 30.0, 12.7, 1.0. Okay, so they want us to first find the equation of the line of best fit. So we're going to go to stat, over to calc, number 4, enter, 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 enter. And you'll notice that we get some crazy decimals with this, and that's okay because these are pretty random sets of data points. So what we're going to do for accuracy is make sure we round to the hundredths place. So my slope for this equation is negative 1.06. because the 0 after the 6 does not change the 6. It keeps it the same. So it's negative 1.06x. And my y-intercept would be 92.31 because the 8 is 5 or more, so it adds 1 more to the 0. So plus 92.31, okay? So that's my line of best fit, that's my equation. But then they want me to use this line of best fit to estimate what would be the average temperature for a city with a latitude of 25. Well, first things first, what is latitude of 25? Latitude of 25 degrees in my table is x, okay? So the reason why I ask that is, with my equation, where do I substitute in 25? Do I substitute it in for y, or do I substitute it in for x? And since 25 is the latitude and latitude is x, then we substitute it in for x. So I'm going to rewrite my equation, but I'm going to substitute x with 25 plus 92.31. And then since they're all on the right side of the equation, I'm just going to type this into my home screen with evaluating 25 as my x. Okay, and I can predict that a latitude of 25 degrees will result in 65.81 degrees Fahrenheit, because that is what y represents, okay? Okay, so we're going to take that same idea with a new set of data points, but I want to point something out for this one. It says the information in the table shows the Olympic 500-meter men's gold medal speed skating time since 1980. Before I can type this into STAT and perform linear regression, we cannot type in the years as is, okay? What we have to do is convert these years to single values. And what I mean by that is, since 1980 is the starting year, that is going to be 0. And then from there, we are going to determine how many years have gone by from 1980. So from 1980 to 1984, 4 years went by. From 1980 to 1988, 8 years went by. From 1980 to 1992, 12 years went by. From 1980 to 1994, 14 years went by. And from 1980 to 1998, 18 years went by. So we cannot leave them in years. We need to convert them to numerical values, okay? So now that I have performed that, we are going to perform linear regression. So that means we're going to type them into STAT. So 0, 4, 8, 12, 14, 18 goes into the left side of the equation or the table. Then 422, 432, 404, 420, 395, and 382 go into the right. Then STAT over to calc number 4, enter, 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 enter. Again, we get these long and crazy decimals. Even if you think we did it wrong, we didn't. We're going to round to the hundredths place. So the slope is actually going to be negative 2.29x, because the 2 does not convert the 9, plus 430.56, because the 0 does not change the 6. We are going to use that information, the equation, to estimate the 500-meter time for the 2012 Olympics. But wait. Again, just when we're dealing with years, we cannot leave it 2012. We have to figure out how many years went by if it started in 1980. So from 1980 to 2012, that's 32 years. So 32 years is the actual value I'm going to substitute. And where do I substitute? Do I substitute it in for y, or do I substitute it in for x? Since years is the x values on my table, we are going to substitute 32 in for x. So y equals negative 2.29 parentheses 32 plus 430.56. And all I do is type that into my home screen. Okay, and I can figure out that after 32 years, they can estimate that the time will be 357.28 seconds. That's how much time it will take to do the 500-meter dash in 2012. Okay, so we've done tables, we talked about years. What happens if they give me a graph? So when they give me a graph, the first thing you need to do is pull the points from the graph, okay? So this is talking about the number of dollars in billions spent on books and maps in the U.S. from 1990 to 1995. Okay, so we first have to start with 1990, and it's hard to tell, but there is a point there. So what is this point? This is 0, 16.5. The next coordinate is 1, 17. The next one is 2, 17.5. The next one is 3, 19. The next one is 4, 20. And the last one is 520.5. Okay, so instead of them giving me a table of values, we had to find them ourselves given a graph. So now that I have my points, we're going to type them into stat, clearing what's there. So 0, 1, 2, 3, 4, 5. And then my values are 16.5, 17, 17.5, 19, 20, and 20.5. Go to stat, over to calc number 4. Again, we are going to round because we do not want to write that whole entire decimal. So y equals 0.87x because the 1 does not change the 7, plus 16.24 because the 8 is 5 or more, so it adds 1 more to the 3. So there's my equation for the line of best fit. And they want us to estimate the amount spent on books in 2005. Now again, we're dealing with years, so we can't just plug in 2005. We have to figure out how many years went by from the starting year, which they said was 1990, to 2005, and that would be 15 years. So I'm actually going to substitute 15 years in for x. So y equals 0.87 parentheses 15 plus 16.24. Again, just perform this in your home screen. And I can predict after 15 years, the amount spent on books in billions, keep in mind, this is not like dollars, is $29.29 in billions. And there's your answer.